Alright guys, so in this last video for the Unit 8 review, we're going to do 3 FRQs, 2 with particle motion, actually 1 with particle motion, and then 2 with rates in and rates out. So this first one is calculator active. It says a particle moves along the y-axis with velocity given with respect to time. It says v of t is equal to t times sine of t squared. This only works for t greater than or equal to 0. So if it's moving along the y-axis, it's moving up and down. So usually when we talk about velocity and how it's moving, we're saying right and left. Positive velocity means it's going to the right. Negative velocity, it's going to the left. Velocity 0, it's not moving at all. So if we're doing this, but moving along the y-axis up and down, positive velocity moving up, negative velocity would just be moving down. It says in which direction, up or down, is the particle moving at the time t is equal to 1.5 and justify your reasoning. So pretty straightforward, especially since it's calculator active. What they want you to do, or what I want you to do, what you should do, is define v of t into your calculator, into Desmos. Like define it, right? V, parentheses t. And just a tidbit, extra information. If you do capital V of t, when you refer to it later, you need to use capital V. You could use lowercase v, and then just when you refer back to it later, use lowercase v in Desmos. There's a difference. Is the particle moving to the up or down? So I'm going to find v of t. So define v of t, and then do in the next line v of 1.5. And your Desmos says 1.167167. Again, shows up all the time. Love it. You might hate it by now. I hope I run into the ground. All the old people taking y'all's jokes is so much fun to me. Anyways, okay, so that's the number. If it's a positive velocity, that means it's moving up. So I would say the particle is moving up at t is equal to 1.5. The reason, because v of 1.5 is greater than 0. And I wouldn't say because it's positive, I would just write greater than 0. Like I would just get used to the inequality form. If you say the word is positive, that's true on this one, but it could mess up some things later in other ones. Find the acceleration of the particle at time t is 1.5. Is the velocity of the particle increasing at 1.5? Okay, so this is not a speeding up, slowing down question. It's a subtle difference. It's wanting to know, is velocity increasing? To know if the velocity is increasing, to know if a function is increasing, its derivative has to be positive. So if its derivative, which is acceleration, is greater than 0, then it is increasing. If the acceleration at 1.5, so the derivative is 0, it is not increasing, it's not decreasing. If the derivative, which is acceleration, is negative, then it is decreasing. But we're not comparing it to velocity. If the velocity and acceleration have the same sign, it's speeding up. If velocity and acceleration have opposite signs, it's slowing down. But this is a subtle difference. This is not what this is asking. So I'm going to find acceleration. Acceleration A. Okay, the pin's not writing. Of course. Why is it not working? Oh, come on. All right, there it goes. Nope, that was my finger. All right, I have to start all the way over. Oh, no, it's not. There it goes. All right, here we go. Okay, so what are we saying? Acceleration, A of 1.5 is equal to V prime of 1.5. And this is what I would plug into my Desmos. And that gives me negative 2.0487 and some more numbers. I would get in the habit of doing this on Desmos on your own, put the decimal spot, then 5 numbers. Not like I did it. And I'm going to say the velocity is not increasing. Just answer the question. Is it increasing? Yes or no? It is not. I know it's decreasing because the derivative is negative. And I'm going to say because v prime of 1.5 is less than 0. The way you can also say it is you say v prime of 1.5 is not positive. I think that's a good explanation there. All right, given that the y of t is the position of the particle at time t, and y of 0 is 3, find y of 2. So this is when we have to know that, like, that initial position formula or equation. I know if I integrate velocity from a to b dt, this tells me the position. I'm going to call it s, or in this case I'm going to call it y of b minus y of a. Remember, this part is displacement. If I start somewhere and I subtract where I finished, that gives me the displacement. So I'm going to use this to help us in this equation, this problem. So I'm going to integrate velocity from 0, because that's the one I'm giving, and I want to find the position at 2, of v of t. V of t is defined, so I don't need to write it all out. That would be equal to y of 2 minus y of 0. So in Desmos, I plug this into the calculator, and I would get a number. And I didn't write the number down that I got. But once I get that number, I know y of 0, y of 2, y of 0 is 3. So whatever number I get here in Desmos, I add 3 to it, and that gives me the position at time 2, which was 3.8268. All right. So that means this displacement right here, the number that I got had to be like 0.8268, right? That's how far it was different from where I started. All right, find the total distance traveled by the particle. So this is displacement. We talked about this in one of the other videos if you watched it. If I move up 7, that means the velocity was 7 for, we'll say, one time interval. So it's going 7 miles per hour for 1 hour straight up. Okay, this makes no sense. Anyways, then it goes down 3 miles per hour for 1 hour. So the displacement is the difference in between the two. So where I started was right here, and where I finished was 4 away. So the displacement would be 4. That's what, if I plug that number in here, it would give me 4. But if I plug in a total distance, I add up positive and positive. I don't care about direction. Total distance is 10. So the total distance formula has the absolute value of velocity. So I plug this into my calculator just like it looks, and I say 1.1731. All right, that's it for this one. Okay, now let's do our rate in and rate out. So the rate in, rate out, it won't ever say this is a rate in, a rate out question. You just have to recognize there's a rate of something entering, a rate of something exiting, a rate of something increasing, and a different rate which is decreasing. So that banana problem that we did in class. So this one's calculator aloud. It says a popular 24-hour health club called Get Swole has 29 people using its facility at time 0. So when they start keeping time, there's already 29 people in there. During the time interval 0 to 20 hours, people are entering the health club at this rate. So this is a rate. And that's the rate that they are entering. Okay, during the same time period, people are leaving the health club at a rate of this. And that is a rate also. So a rate in and a rate out. People are coming and people are going. Is the number of people in the facility increasing or decreasing at time 11? Explain your reasoning. So what I want to do here is simply compare the rates. If I find the rate at which people are entering, and I find the rate that people are exiting, and compare the two, if the rate that they're entering is greater than the rate that they're exiting, then the number of people is increasing. There's more people in there because there's more people coming in than there are leaving. So I would define in my calculator or into Desmos, E of t is this, L of t is that, and then in a separate line, type in E of 11. E of 11, I got 8.822. Okay, again, you do this and write the actual decimals with 5 numbers afterward. I just rounded on this one. This is before I used to actually put decimal and then 5 numbers. So the numbers might be slightly different. All right, so those are the 2 numbers, and I'm going to compare them. So the rate that people are entering the gym at time 11 is greater than the rate that they're leaving. So my answer to the question is at t is equal to 11, the number of people in the gym is increasing. And my simple reason is because E of 11 is greater than L of 11. And if you ever refer to like numbers like E of 11, make sure you write what the number is, the number that the calculator gave you. So just little things that you make sure you're writing down to get full credit. Okay, to the nearest whole number, how many people are in the health club at time t is equal to 20? All right, so at time 20, I have to add up all the people that entered, and I gotta subtract all the people that exited, and then add 29 because there's already 29 people in there. So 29 plus, to add up all the number of people entered, the total number, I'm going to integrate a rate. So from 0 to 20 of E of t dt. And I'm going to subtract all the people that exited during that interval. So from 0 to 20, L of t dt. So that's the setup I would want to write on the paper. If I just did this in my calculator, I typed all this into my calculator, but I didn't write it on my paper, but I wrote 56 people because that's what the calculator tells you, then I think you're not going to get full credit. Make sure you're writing whatever you type into Desmos, write it on your paper. Now, this was already on your paper, the rate equations. So you don't need to write out what E of t is, they know. But make sure you're writing like this stuff down here. All right, so I had some of that on there. Okay. At what time is the amount of people in the health club a maximum? Justify your answer. All right, hopefully by now you're realizing anytime they ask you a maximum or a highest or a greatest or the most or the least, if they have one of those phrases that mean the absolute max or min, this is a candidate's test question. And if you recognize that, it would not hurt to write candidate's test. That way the reader, whoever's grading your paper, kind of knows, okay, they know candidate's test. Now I'm going to kind of look if they know what the actual candidates are. All right, so my candidates are the critical values and the endpoints. So the endpoints are 0 and 20. Those are 2 candidates. So I'm going to kind of get in the habit of always writing out a table. I think it's helpful. I'm going to write out candidates. And then in this right column, it's a function value. But it's the function value of what? The amount of people. Nowhere on this problem did they tell us this is what we're going to say the function is called, the amount of people function. So we're just going to say, we're going to call it A of t. You can call it anything. A of t is the amount of people in the gym at any moment of time, which correlates really close to this up here, right? This told us the amount of people at the moment, time was 20, it was 56. So our A of t, in more general terms, for any value of t, now here's a tricky part too. I've already defined these as t's. So I'm actually going to call this A of x. Now I could go through and change my Desmos. I could change these to x's. E of x, that's an x, this is an x. I could do that. And then I could call this A of t is 29 plus the integral from 0 to t. And then this would be E of x dx. That's the rate that they're entering. I subtract the rate that they're exiting. Subtract integral from 0 to t, and then we call it L of x dx. We could do it that way. The most important thing to know is these cannot all be the same letters. Oh, that's a plus sign, moron. All right, it's plus, or sorry, t. Those are t's. That's where I would plug in. So if I want to find the amount of people at time 0, I would do a of 0, means I plug in 0 up here. If I wanted to find the amount of people in the gym at time 3, I'd say a of 3 is equal to 29 plus something 3. And then you plug in those values there. So those just can't match. What I did when I did this earlier on Desmos, I made this a of x because I had already defined the function in terms of t. I didn't want to rewrite those. So just to show you, this might mess you up. This might make it better. I don't know what's going to happen. Hopefully this is helpful. I'll call this x and then t and t. But anyways, those variables can't match. All right, so all that said, the candidates are 0 and 20 for sure. And then wherever the critical values of a are. So those relative min and max. So I've got to be able to remember, okay, relative min and max, those happen when my derivative is 0. I need to test those points. So I need to find where's a prime of x equal to 0. Well, first of all, let's find a prime. There's so much calculus in the problem, it's lovely. All right, so the derivative of a, okay, so I take the derivative of each piece. The derivative of 29, the derivative of constant is just 0. The derivative of this, that's that fundamental thing of calculus, right? It's just e to x. Now it's in terms of x. The derivative of the integral, those operations are inverses of each other, so it just cancels. I say minus L of, plug x in here. And we should remember, multiply by the derivative of x, multiply by the chain, but times 1, doesn't really matter. All right, so a prime of x is equal to e of x minus L of x. So I'm trying to find when is that equal to 0. When are those two, when it's equal to 0 is whenever the two functions are equal to each other. So I did that and I plotted on my graph. I graphed e of t and L of t. Wherever those are equal to each other, that's your other candidate. So 14.66397. 14.6, I already forgot. 14.66397. 14.6, I already forgot. This is terrible. 66397. 66397. All right, so once you have the candidates on a calculator active question, it's not so bad. A of 0, we know is 29 because they told us that, right? Now, A is not acceleration. I just got confused for myself for a second. A is the amount of people in the gym at those time values. So A of 9 is 0. A of 14.66 whatever, just plug into your calculator. There they are. But make sure you're writing those values in your table. 67, it happened again. Look at that. What a day. What a great problem. 672876. 2876. 67.2876. I think it was a 0. And then at 20, time 20, 56.333. I think we're going to round to the nearest whole number, right? 56.333. It wants to know amount of people in the healthcare when it's at maximum. So is the amount of people at what time? So it wants to know the time at t equals 14.6639. I think that's a 1. The amount of people in the gym was at its max. And its maximum was 67 people. But I didn't write that because I didn't ask. All right, last question. review for Unit 8 is almost done. Oh no, this is still part. Oh, come on. Okay, if the health club has less than 10 people using its facility, the owner will serve everyone a special health drink. That's nice. Set up but do not solve an inequality involving one or more integrals that could be used to find the time h when the number of people in the health club is less than or equal to 10. So less than or equal to 10. So it's 29 plus the integral from 0 to h, the rate that people are leaving or entering. That absolutely matters. Entering. Minus the integral from 0 to h, L of t dt. I think that's pretty straightforward. H is the variable. This hopefully helps you understand, like, whoops. I could solve this for h. What value of h would make that, what would be the time where there were 10 people or less? Yeah, that's good. I don't know what else to say about that. Sorry. Okay. Calculator allowed. Yay. A parking garage has 230 cars in it when it opens at 8 a.m. On the interval from 0 to 10, cars are entering the parking garage at this rate. It's a rate. And they're leaving. Okay, rate. So rate in, rate out. Rate entering, rate exiting. Beginning at 9 a.m. and continuing till 6. Ooh, so that's kind of tricky. So 8 a.m. is time is 0. 9 a.m. is when they start to leave. So this is good from 0 to 10, but rate leaving starts at 1 and ends at 10. They're both measured in cars per hour, while t is measured in hours. Okay, how many cars into the parking garage over the interval from 0 to 10? So that's only integrating the e of t rate. So I went and plugged that into the calculator, into Desmos, and I got 510.159945, and then I would just say cars. It doesn't say write the units, so I mean I think you get away without writing cars because how many? We'll get that many cars. But it wouldn't hurt to just write cars. All right, find e prime of 5. Using correct units, explain the meaning of the value in context of this problem. All right, so e of 5, I wrote this down earlier. Oh, sorry, e prime of 5. So in my calculator, I have defined, no, I didn't. So I should, in my calculator, define e of t. I would use capital E. If you use lowercase e, I think it thinks that's the number e, so don't do that. Capital E of t is 58 cosine of point, well, okay, I'm not talking. Define that and then type in e prime of 5 in the next line, and it tells us it's negative 1.627 something. Okay, that's the number. I found it. Maybe there's a point there. Okay, using correct units, explain the meaning of this value. So I would say e prime of 5 means, okay, I'm bad at English. You write this in a better way that might make more sense, like flow off the tongue. But that means, okay, so the derivative tells you how the function is changing. But this function was already a rate. So the derivative is a rate. So if I take the derivative of a rate, it's the rate of a rate. So I'm going to say e prime of 5 means the rate at which cars enter the lot at t equals 5. And sometimes you write at t equals 5 at the very end. I wrote it here because I remembered it. Is, okay, so I already said the rate because that's what e was all about. Whatever e is about, say, when you find the derivative, that means that function, e of t, which is the rate at which cars enter the lot, is decreasing. I'm going to say decreasing because it's negative. At a rate of, but now I say positive, 1.627. I don't use the sign there. I always just do the absolute value of that rate. The negative comes into play when I said decreasing. So if that was a positive, I would have said increasing at a rate and still that number. And then my units. Cars per hour. And then sometimes I would have I could have just taken this part right here and just moved it at time. So right at the end. As long as you have all the components there, you'll get it right. It doesn't be in the same order. Write it in a way that like flows off your tongue better. All right, are we almost done? One more. 2 more. Okay, find the number of cars in the parking lot at time t equals 10. Show the word leads to your answer. All right, so there were already 230 cars in the lot, and then they start increasing, or they start entering at a rate, and I'm going to say from 0 to 10, they are entering at this rate e of t. I don't need to write out the function because it's already defined. And then this will tell me the total number of cars that would have entered the parking garage in those 10 hours. And I'll subtract the total number of cars that entered, but I'd be careful, it's not starting at 0, it starts at 1 to 10 L of t dt. There's a setup. Plug that into your calculator, you get 665.103 cars. Find the number of cars. It did not say find to the nearest whole car. So if it doesn't say to the nearest whole, it doesn't make sense, but just put the decimals, even though we're talking about whole cars. You can't have a 10% of a car come in to the parking lot. It doesn't matter. Use the whole thing. On the AP exam, they'll probably say to the nearest car, just to avoid any confusion. But if they don't, put the decimal. All right, find the time when the number of cars in the parking garage is at its maximum. Or maximum. Wow, maximum. Okay, that's spelled wrong, I think. Yeah, because this is how it's spelled right. Embarrassing. All right, this is ridiculous. If it wasn't the last question, I would go back and changed it to avoid this, but it's too late now. I'm not recording this all over again. All right, find the time. Okay, so this is a candidate test question. All right, candidates test. So I have my function, basically, that represents the amount of cars. I'll call it A of x. That's 2 of 30 plus 0 to x of e of t dt minus the integral from 1 to x L of t dt. If this is a function of x, but really it's time, but I've already got time defined here, but the function is where I plug in the x values, which would be here. These are t values, which technically is what I'm looking for, t values, but those can't all be the same. Anyways, so again, this is very similar to that last one. The candidates, and then A of x values. Candidates are 0 to 10, because it says that's my interval. Those are always on there. Maybe if you write both those on there, they give you a point. Who knows? Okay, I also need to find where is the derivative. So I need to find critical values. Critical values are relative min and max. That's where the max could happen on an interval. And we kind of just know A prime of x is equal to E of x minus L of x. So I'm trying to find where E of x is equal to L of x. And that happens at the value 2.5212. So in Desmos, graph one, graph the other, there would be E of t, L of t. There's your number. And then from here, just type them in. You've defined out what A is. And then write A of 0 is 230. A of 2.5, I wrote this down, was 264.425. And at 10, it's 665.103. So what's what the question say? To the nearest whole number, okay, so whole car, what's the maximum number of cars in the parking garage? So the last one asked, when did it happen? This one says, what is the max? The max number of cars in the garage on on that interval is 665 cars. It doesn't ask when, but I'm going to tell it when. No, I'm not. Don't do it, because if I mess it up, I'll look stupid. To the nearest whole number, that's the max. Boom. All right, so hopefully this was helpful. Hopefully this kind of reviewed everything and you're ready to take the test. Thanks for watching, and if you have any questions, maybe leave them in the comments. And then if you are reading the comments and you see a question was asked and you know how to answer it, maybe answer it for them. So thanks for watching, and I will see you in class next time. Bye.